Hello everyone, today I want to test something interesting. Can a graphite from a simple pencil be used as a soldering iron? I will build a small setup using a pencil graphite rod, a few simple components and a power supply. In this video we will see how hot the graphite can get and whether it can eventually melt a solder. First we need to make a soldering iron. So I am starting with an HB2 pencil. First I need to peel it. Now I have the bare graphite from the pencil. Next, to make a graphite holder, I will use two metal plates connected with a bolt with washer and a nut. Then add the bolt, washer and nut again to create a graphite holder. Next, insert the graphite and tighten it. Now just need to connect it to the power. For this purpose I will use simple cables. First, strip part of the insulation from the cable. Then wrap it around the bolt and tighten it with a nut. Strip part of the insulation from the second cable. Carefully wrap the cable around it, making sure not to break the fragile graphite. I put the cable through the holes, but starting from the first one to make it more stable. Then attach the battery connector. Use insulation tape to prevent a short circuit. This is a chopping board, but today I will use it as a multi-purpose tool. For the test I will use a small bulb, a quick battery unboxing, Let's start with a 9-volt battery and see what happens. Now I will give it some time to heat up. And nothing happened. I don't feel any heat. But I am desperately trying to melt the solder. It's not okay, the temperature is 23 Celsius, which is basically room temperature. There was some kind of accident. After that, the soldering iron became more compact. Okay, the resistance is almost 2000 ohms. That's quite high. Now we see what happens with a 12 watts power supply. And nothing happens, as expected. The temperature is only about 24 degrees Celsius, still a room temperature. Now I am doing a test to see how the bulb's brightness changes as the resistance varies while sliding the cable along the graphite, using a 12 watts power supply. And I noticed that the bulb works only when the cables touch each other, because of the graphite's high resistance. So far, everything with the HB2 pencil has been unsuccessful. Now I am switching to a different type, an HB pencil. I connected the 9 volts battery, but I don't feel any heat. With the 12 watts power supply I noticed some changes. Now we can see that the graphite temperature has reached 96 degrees Celsius. But it's still not enough temperature to melt the solder. Now you can see that the bulb's brightness changes slightly as I slide the cable. We can see that as the cable position changes, the fan sounds changes as well. It works like a fan speed controller. Now I am measuring how the fan speed varies as the cable position changes along the graphite. As the distance between the cables decreases, the resistance drops, causing the speed to increase. By moving the cable along the graphite, we can observe the resistance increasing from 5 ohms to 11 ohms. And when we move the cable back, the resistance decreases again from 11 to 5 ohms. The graphite rod is approximately 11 centimeters long. When I switched to a 12 watt power supply, I noticed the cable started heating up quickly. To avoid overheating and possible damage, I decided to make a small upgrade by stripping the cable insulation. Okay, now let's test with the 24 watts power supply and see what happens. And finally we reached the point where it actually melts the solder. The graphite gets so hot that even after I turn off the power, it keeps melting the solder for a while. I noticed that the cable was still getting too hot. To reduce the temperature, I decided to connect the cable to the graphite rod using a bolt, a washer and a nut. Now we can see again how easily the solder melts. And see how hot the graphite rod gets. So in the end we can see that a soldering iron made with an 11 cm piece of graphite from an HB pencil can reach a temperature high enough to melt a solder when powered by a 25 watts power supply. The 12 watts power supply and the 9-volt battery were simply not strong enough to produce the required heat. Thank you for watching.